Humans can live full, vibrant, healthy lives for 200 years or more. Our mission at Galahad Life Sciences is to slow and ultimately reverse aging so humans can live their full biological potential. This series of podcasts will introduce you to what I have learned in Live Long, Live Well. I will introduce you to disciplines that are on point, like medicine, biology, exercise, and nutrition. I will also introduce you to disciplines that seem tangential, like physics, history, and psychology, all for the purpose of clarifying our thinking about one of humanity's greatest challenges, aging. Welcome to Live Long, Live Well. Hi folks, I'm Steve Loyd, CEO, Galahad Biosciences. About 25 years ago, I moved into this new field of biotechnology. Midlife, 55 years old, my health was declining, and I'd also studied the life expectancy charts. When I was born, my life expectancy was 68. At age 55, with declining health and my family's history, I sort of figured that, well, maybe I've got 13 more good years to deal with some of life's issues. I'd had a successful career in finance, was a professor of finance at the University of Washington. My biotech experience was way beyond me because I'd been admitted to medical school, but that was an entirely new career for me. Sold my home, sold my business, and jumped into becoming a biotech expert. My goal was to slow or reverse biological aging with an ultimate goal of extending human life and health to 200 years. I had a very short time to come up with those ideas, those solutions. I needed good ideas that worked and fast. Now, the current medical model was broken, and I knew that. I recognized it. From a financial perspective, from a financial analyst perspective, I knew it cost too much. We were getting diminishing returns, and it was time to rethink the medical model. Now, that's standard, financial analysis. But what was the new approach? I knew that AI was beginning to develop some new biotech paradigms, and it was not going to be something fast enough for my mindset. I remember Arthur Erickson, who was a world-famous architect, once said that severe constraints push creativity to new heights. So, figuring we had a very little time frame to get the job done, I decided to adopt 3 rules. Galahad's new paradigm for biotech discovery. First, do no harm. Medicine has forgotten that one. In fact, most of our prescriptions seem to have negative side effects. But first, do no harm. Second, new discovery lies between disciplines, not going deeper into complexity, but finding space between existing disciplines that hasn't been explored before. That's where new discovery lies. And third, follow evolutionary biology for insights to see what will work. Let's get into these a little bit deeper so that you understand where we're coming from. So first, do no harm. Safety is not easy, but it is necessary. We want to choose materials to work with very carefully. We were not going to go down the field of inventing a new material that we didn't know what their likely side effects were. So we were only going to use pure materials that were safe and were very basic, but we could test how we put them together on cells to determine at the cellular level if it was effective and safe, and we'd test on animals to find out what toxicities there were. The result is we were introducing new products with no negative side effects. This is mind-boggling. The FDA requires that we carry adverse event notebooks on all of our products. Our notebooks are empty in spite of having over millions of doses developed and shared and tested. Our second discipline was to look between existing disciplines. That was an ironclad rule for discovery. Like a running back looking for an opening in the line instead of running headlong into everybody that's in your way. You find an opening and you run for it. You go for it. Now, what does that mean in terms of biotech? First of all, developing your new ideas came from researchers in a wide range of areas, from biotechnology to history to culture. We were looking for ideas. In the meantime, we are looking at how to execute on these ideas. We drew new talent in. So, for example, designers, from computer chip designers to space shuttle tile new materials developers, were brought in together to determine how we could execute on the ideas that were developed in research and in biology and history and those fields. And then simultaneously, we were testing for safety. And when we got to the human level of testing, we weren't testing to see if it reduced disease conditions. We were looking at biomarkers of vitality. That is, looking for indications that the body is functioning at a higher level, not trying to fight a disease. The result is that we have new solutions and products that really, really work. The third check is the evolutionary biology check. The question is, does that discovery, does its way of working make sense from a biological perspective? That has a huge advantage. Not looking at it from a technological perspective, but a biological perspective. So let's say, for example, we had a technical solution to get from point A to point B. You know that what you do is you launch a spaceship into geosynchronous orbit, thousands of them, so individuals can hold their handheld computer, their cell phone, to give them direction on where to go. Wow, that is expensive. It's a high-tech solution. It's a marvel of engineering. And biology has to take another approach. Biology has to be incredibly efficient. Biology does not waste energy. What is the solution that birds have for getting around? Well, they have a protein that is specially developed in their eye to get them thousands of miles from point A to point B so that they can nest in their appropriate places. Evolutionary biology is one of the hallmarks of being able to come up with efficient solutions that really work. The result, we have new, faster, low-cost products that actually improve cellular function at the mitochondrial level. That's a big step forward, and the purpose of these podcasts to explore that science is to clarify our thinking around one of humanity's greatest challenges, aging. Now, we don't offer medical advice, we offer life advice, and we will be interviewing people who are leaders in biotechnology in a wide range of areas, from the hard sciences of biology and medicine to the softer sciences that can explore a new way of looking and understanding the aging process. Join me. I'll look forward to spending time. Thank you.
Father,